This is Algebra 1, Lesson 2-7, Square Roots and Real Numbers. The learning goal today is that you learn how to find the square root of a number and what a square root is, and be able to classify and order real numbers. So to begin with, square root is simply one of two equal factors of a number. So if you think of the square root of 64, 8 times 8 is 64. So the square root of 64 would be 8. But so is negative 8 times negative 8. That will also be 64. So this could also be negative 8. So really, every square root has two answers. Now, so you may wonder, how do you determine which one they want? If you look at this slide, you'll notice that I've made a list for you down here of the perfect squares, and they would be 1 times 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 squared is 36, and so on. So you really need to memorize those because you need to know what a perfect square is and what they are. There's really not that many of them that you ever see, and really if you go up to about 144, that's probably good enough to suffice for now. Alright, so perfect squares. A perfect square is the number produced when equal factors are multiplied. So I've already showed you that the square root of a perfect square is a rational number. It's usually a whole number. Now the square root of 64 could be 8 or negative 8. So how do you know which one they want? Well, if you look right here, notice there's nothing in front of the square root symbol. So they want the principal square root. And we say that that would be 8. Now, if you see a negative sign in front of the square root symbol, they want the negative root, and so the answer would be negative 8. Plus or minus the square root of 64 means that they want both roots, plus and minus 8. Okay, let's try this one. Number 1, find the square root of negative square root of 49 over 256. All right, so you need to think, what can I multiply by itself, or what equal factors would multiply to be 49 over 256? Well, the top is easy. I know that 7 times 7 equals 49. And then I know that 16 times 16 equals 256. And I know that the negative sign out front of the radical symbol means that they want the negative root. So the answer is going to be negative 7/16. Okay, so let's review. A rational number are numbers that can be expressed as repeating or terminating decimals, or in the form a over b, where a and b are integers and b does not equal 0. So basically you can make them into a fraction. So for example, negative square root of 25, that would just be negative 5. You can put negative 5 over 1 and it's a fraction. 5/4 is a fraction. 2 and 86/100 repeating is you can make that into a fraction. Negative 5 and 1/3, 125 thousandths, the number 12. The square root of 81 is just 9. So, what can you not put into a fraction? And those would be called irrational numbers. And those are numbers that cannot be expressed as terminating or repeating decimals, or of the form a over b. So that would be the square root of any number that's not a perfect square. So the negative square root of 26. Pi. 1.73205080 never ends, never repeats. And then negative 3.4144144441, it doesn't repeat. Okay, so natural numbers would be the numbers like 1, 2, 3, 4, 5. Whole numbers are 0, 1, 2, 3, 4. Integers would be ... -3, -2, -1, 0, 1, 2, 3. And of course the rational numbers we've already talked about, and the irrational numbers. Okay, so let's look at this chart. We want to take each number in the first column and decide which type of real number it is. So let's start with 5 over 22. Is that natural? Absolutely not. It's a fraction. Natural numbers are numbers like 1, 2, 3, 4. Is it a whole number? No. Is it an integer? No. Is it rational? Absolutely. It's a fraction. If it's rational, it's not irrational. Is it real? Absolutely. In fact, every single number that you've ever seen is real. So we can just go ahead and check that whole column. The square root of 121 is 11, so that's actually natural. It's actually whole, it's an integer, and it's rational. Square root of 56, 56 is not a perfect square. So that means that if you take the square root of 56, you will get an irrational number because it's never going to end, never going to repeat. Negative 36 over 4 is actually negative 9. So that's not natural, not whole. It is an integer, and it is rational. Negative 0.2 and the 2 repeats, that's not natural, whole, or an integer. It will be rational because a repeating decimal can be made into a fraction. Okay, now the next set of problems, they're asking you to graph the solution set for each. So for number 1, this simply means all the numbers that are greater than negative 2. So you don't include negative 2 because negative 2 is not greater than itself. So we put an open circle on negative 2 and we shade everything greater than that. So that means we go to the right on the number line and then we want to shade in the arrow to the right. Number 2, all the numbers less than or equal to 4.5, which would be halfway between 4 and 5. We want a closed circle because of the equal sign. We do include 4.5. And then we include everything less than that, so we shade to the left and the arrow on the left. All right, this next set we're just comparing using less than, greater than, or equal. So what you'd want to do is you want to compare the square root of 19 with 3.8 repeating. So we all know that 3.8 repeating looks like this. The 8 just keeps repeating. Now the square root of 19, I want to think to myself, what perfect squares would 19 be between? Well, I know 16 is a perfect square, and I know that 25 is a perfect square. And I know that 16, the square root of that is 4, and the square root of 25 is 5. And 19 is only 3 away from 16, and it's 6 away from 25. So it's actually going to be closer to 4, a little bit more than 4. So I know it's greater than 3 anything. It doesn't really matter. I know it's more than 3. Number 2, 7.2 repeating. The 2 just keeps repeating. And then the square root of 52, I know that 52 is really close to 49 and it's really close to 64. And I know the square root of 49 is 7 and the square root of 64 is 8. Now let's see. It's only 3 away from 49, and 64, it's a lot farther away from 64, like 12 away. So it's actually going to be closer to 7. And then if you use your calculator to take the square root, you actually get 7.2111026. Now, comparing the two decimals, you'll notice the ones place are the same. The tenths places are the same. However, the hundredths place, you have a 2 and a 1. So 2 is greater, so we're going to put a greater than symbol. All right, that's it.